Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, we are going to look at the concept of the product rule. And this, of course, is going to be a complementary discussion on the various aspects we have looked at on the concept of differentiation. Now, in this particular case, I'm going to look at another set of a rule, which, of course, is going to complement on the three specific aspects we have discussed on the concept of the chain rule. Therefore, we have discussed about the quotient rule. And then we talked about the reciprocal rule. And then, of course, I'm going to look at the product rule as a final set of these specific rules which are applicable under the broader concept of differentiation. And these are going to collaboratively assist us solve various question sets that we may come across, especially in the normal algebra and geometry. So in this particular discussion, I'm going to look at a specific theorem, which of course, as I've been doing for these three specific first set of our discussion, of course, is going to be very essential in us understanding this specific concept of the product rule. So this, of course, we are going to consider two specific functions. So if the function f and g are differentiable, if f and g are differentiable functions at x, and fg, which is a product of the two functions, is differentiable at x. So if the product over these two specific functions, which I have indicated that is differentiable at x, then we are going to give the product over this, or the derivative of this specific product as a sum of f prime of x gx plus fx g prime of x given as such. So this basically is going to give an impression that if we have the product over two numbers or two functions basically which are differentiable at x, their product can be given as fg, and of course fg is differentiable at this particular value of x at x, and fg prime of x is given as the value of f prime of x gx plus fx g prime of x given as such. So we're going to look at perhaps an expanded form, or perhaps try to identify, or perhaps try to evaluate this and see whether this basically is going to be true. So we're going to use perhaps an evaluation on the board, and I hope you have understood this. So this first set of all these elements of this particular equation indicates that first we differentiate this particular function and we hold this one constant, and then we find the sum of this one plus the first function that was differentiated is held constant, and then we differentiate the second function, which of course was not differentiated from the first of course element of this specific equation. So therefore I'm going to use that as specific analogy. So therefore I'm going to have to do one of the evaluations which is going to prove basically that that's the rule that is going to be applicable. So I'm going to have this one given as such, f prime over x dx plus fx g prime over x given as such. So this is the specific equation we're going to do. So we're going to do an evaluation and basically see whether this is applicable. So we can write this one in terms of that small difference in x. Therefore, f g or f g, and then we're going to have that small increment in h minus f g x. So basically we have just taken the difference quotient of this specific part of the equation I mentioned the concept of the differential quotient whenever I was talking about the concept of a derivative. So therefore, this basically is going to be given as this particular section of the difference in the small increment in f for a single function minus fx over h. So that basically implies the difference quotient, and therefore I'm going to write this difference quotient as the product of the two functions for f and g. And therefore I'm going to have this one divided by h given as such, and that is going to give me the derivative of this particular function. So this basically is going to be given in terms of f into x plus h. So that's for a small increment in the first function for f, and then I'm going to have this one as a product with a small increment of that specific function in the g, which is going to be given as g plus g into x plus h. So basically this is just an expansion of this first set of the equation I've given on the board, and this is going to be fx gx for this second set of this specific function for the numerator of the difference quotient given as such, and all of this is going to be given as over h. And therefore the next step we're going to take is try to evaluate this particular section of the right side of the equation and see basically whether it's going to be giving us this specific summation so or rather this specific product. So therefore I'm going to have this given as a general equation under this 1 over h, and therefore the inner side of this specific equation is going to be represented using x plus h given as such. So that's a section that I'm going to give for f, and putting these like terms for f together, the first function, therefore I'm going to have this first set given as such, and of course from the product rule from this particular product rule I'm therefore going to find the derivative, which is the derivative times 1 over h given as f prime over x. So basically this is going to form the numerator of f x plus h minus f x given as such, as we have been doing it for finding the first derivative respectively. So this is going to form the first bit for f prime x, and for the g x plus h, that is going to be held constant as we have done for this, and therefore that is going still to remain as g into x plus h given as such. So I've differentiated the first section and I left the second one constant as such, and that is going to form the first set of this particular equation. So I'm going to have to add that x, which is going to still remain fx, and then this specific set of the products for the second function of g prime over x. I'm going to find the g prime of x by finding the difference between gx plus h minus gx, just as I've done for the first set. So this is going to appear in form of this specific expression. I hope this is going to be enough for this. So it's going to be given as g x plus h minus g x, which is going to form the denominator of this specific set of the second function, and then I'm going to have all of it multiplied by 1 over h given as such. So if we look at this specific expression, then therefore this is going to be under the common factor of 1 over h, but the first section of this is going to imply the f prime over x, and then this is going to be held constant, and then I'm going to have it plus fx g prime over x, which is basically going to be given as such. So basically this is an expansion and a rearrangement of this second part of the equation that I've given above, and then we're going to have this one finally given in terms of this specific expression. So this implies that as the value of h tends to 0, so I've explained the concept of a limit and given this particular small increment in x. So as the value of h tends to 0, then therefore we're going to reduce this specific expression or part of this equation, reducing into this. So implying that indeed fg prime over x can be given in terms of f prime over x gx plus fx plus g prime of x given as such. So this is going to be applicable as we go ahead, and of course we can give this one basically in differential form in terms of just give it to us. So this expression can be given as such for the product rule, and it can as well be given in differential form, whereby we're going to have d over dx over this specific product over fx dx, and then this is going to give us the product which we have given for the differentiable function over x, and then we hold the gx constant plus dg over dx, and then we hold fx constant given as such. So this is going to appear in terms of a derivative given as such, and of course this is going to be the general representation for the differential notation and the normal representation of the product rule in this specific case. So apart from the product rule, we're going to see that the chain rule, the quotient rule, and of course the reciprocal rule are going to be applied in various ways, and in some cases we're going to apply them of course in a complementary way in order to solve some of the equations that we may come across, especially in differentiation of our trigonometric functions. So kindly check our description boxes for various links of other videos that we're going to do on the concept of differentiation, and that is going to play a vital role in us understanding the general aspect of the differential calculus that we are doing, and the one that we have already done. So that is it for now, guys. By God bless you. Catch us in our next video.